Hello everyone, welcome back to my workbench, up here in the study at Donget's Model Railway. This is my 2021 release Hornby APT. One of the known problems with this release is that it has poor traction. With a 10-car rake it cannot climb out of the storage yard. This is around 2.5% rising gradient on a third radius curve, so it's a challenge, but it's not an unrealistic one. All my other 4-axle locos come up here no problem, regardless of manufacturer. This run was with the development coach instead of the dummy NDM. The dummy NDM is actually one of the least free-running vehicles in the set, so it's even worse at climbing with that in the set. Hornby didn't seem to consider this a problem at the time. The best suggestion for anyone experiencing this problem was to buy the single NDM, which, because it sold out instantly, no one could get hold of. The next best suggestion was to buy enough spare parts to motorise the NDM. Unfortunately, how to use them was unclear, in particular this piece here, which doesn't show how the drive is transferred, and also doesn't seem to come in any of the spares packs Hornby sell. So first I'm going to take the motored NDM apart so I have a reference to aim for. To get one of these apart, the first thing you need to do is take the pantograph off. The pantograph is secured to the top of the bogie with 2 screws. They are hidden quite deep inside. With these removed, the pantograph will lift straight out. The screws were in the top of each foot here. After this, there are 2 screws that hold the body on. These are removed from underneath through a small hole in the end of the bogie. There are also clips holding the body together. Start at the holes for the lifting jacks and carefully prise the upper body out and up. Do this on both sides and the top will lift straight off.
Ooh, and this is on YouTube. Bacon grease choc chip cookies.
Oh, thanks.
Oh, sorry, were you recording? Can you redo that bit more?
Note from the future. In July, the 2023 version of the APT is now available, including another single NDM, and that has several changes. While I would not recommend running the old and new NDMs in multiple, the new one reportedly has improved traction. So replacing your 2021 NDM with a 2023 one may work. Another issue is apparently it has different couplers, so you'd have to solve that one. But anyway, back to February, and I'm about to get the body shell to finally pop off. To get at the inner motor shaft so I can see how the universal joint is supposed to connect to the motor, first I need to take the bogies out. These are a clip fit at the top of the chassis. I squeezed the clip with some pliers as it didn't feel like it wanted to pull out without assistance. One end of the universal joint has a pair of pins which slot into the flywheel. This locates the drive shaft in the flywheel and provides the drive. Without the pins it would still go in, but it wouldn't have a positive drive and you'd end up with a slipping motor. This is how it's supposed to work. These parts are not in the APT spares. The drive shafts do not come with them, and the motor does not come with them. I bought my parts from New Modeller's shop, and I spoke to Simon about how to get these missing pieces. He recommended two options. One is to buy motor X7229, which is from the Class 800. This is an older motor with different performance characteristics to the APT motor, but it has the same design of flywheels and does include the critical missing pieces. At £30, this is a very expensive way of getting two tiny pieces of plastic, but using these with the actual NDM spares motor is the only way to get an exactly like factory result. The better suggested alternative is to order motor X7691, which is from the latest version of the Class 91. This is the same base motor as the APT, but has a revised drive system avoiding the slotted flywheels and includes all the necessary parts to connect the APT drive shafts. If I was motorising another dummy NDM, I'd be buying this motor and not the APT motor. Simon did offer that if you'd bought the NDM motor from New Modeller's shop, they'd be willing to exchange an unopened NDM motor for a Class 91 motor. Unfortunately, I'd already opened mine, so I didn't take him up on this. And note from the future, that was in February, so I don't know if that offer's still valid or not. Please don't harass him if it's not valid anymore. However, with the parts already here anyway, let's see what I can achieve with what I have. In the driveshaft pack, you get the worm that is in the top of the bogie. You also get the same worm already fitted to the top of the bogie, including the end of the universal joint. That means I can take the universal joint from this end, as I have duplicates. What it doesn't have are the pins to pick up the drive, but I can fix that. If I drill the right size hole straight through the middle of it, I can put a rod through, and this will provide the two pins to pick up the drive. The cut leg of a 1N5401 diode looks like the perfect size, and I have loads of them lying about. I found a 1mm hole was too small, but a 1.5mm hole was too large. Backing the 1.5mm drill out of the hole without cleaning the hole properly, leaving it full of flash, provided a solid interference fit for the component leg. The assembled universal joint end slid neatly into place into the motor. All I need to do now is trim it so that nothing sticks out outside the flywheel. If you are enjoying this video or finding it useful, hit the like button. If you want to see more of my layout or the stock I run on it, hit the subscribe button. If you have a question, comment or suggestion, write it in the comment section below. Time to put it all together. The motor snaps into the cradle. The cradle screws to the lower chassis block with 4 little rubber O-rings to reduce vibration and noise. The 2 upper chassis halves assemble around the motor and screw to the lower chassis block. The tiny PCB with the 8-pin DCC socket screws to the bottom of the chassis. Careful how you route the wiring. Follow the stock NDM as a guide. Remember, the body needs to tilt around this chassis. You have less space than in non-tilting models, and it's much easier for things to snag or bind. Carefully solder the motor leads. Put the inner drive shafts in now. Once it's sitting in the lower body, you'll have a lot less space. The bogies are a serious challenge. The tabs for the pickups are way down inside, and you can't reach them how they're shipped. You'll need to take them apart. The pickups are attached to the bogie frame keeper plate assembly, and even with the gear tower removed, soldering them needs a careful hand to avoid making a mess of the plastic. You can solder the pickups outside the lower body and put the bogie frames through the holes in the lower body later. Make sure you're consistent about which side is red and which side is black. Accidentally swapping one set of pickups will result in a dead short. I found reassembling the bogies to be an awkward challenge as the axles are not retained in the gear towers. Refitting the frames such that the axles sit properly with the gears meshed and have the pickups properly on the back of the wheels was very difficult. When fitting the wiring, there's no indication which side of the chassis should be red and which side should be black. This matters because you want DCC forward to point in the same direction when coupled, despite both of the vehicles having the pantograph at opposite ends. Which way up you mount the motor even matters. Flipping this so that the top side is on the bottom will swap the pins over, meaning the vehicle goes the wrong way. I had two of the same type of coupling on the bogies I got, so I needed to swap one out with that from the original unpowered bogies to get one of each type. To give this the best possible chance of working, I'm fitting two new matched decoders. Same manufacturer, same version number. The previous decoder I had fitted to the factory NDM is the same type, but several revisions earlier, and I could easily see something like the ABT implementation being subtly different, causing the two motors to fight when the block goes into ABC or something. Or something like that, anyway. I'm mounting the decoders up on top of the chassis to allow more space for the body to tilt around the chassis. I found when mounted underneath there was not enough space between the socket, the decoder itself, and the bottom of the body shell to allow the tilting to operate smoothly. When the body shell caught on the decoder or its wiring, it would then stop the tilt at a particular point. That can affect the rotation of the bogies, which can then derail the train. A quick test on the test track reveals I've got something wrong. They're going in opposite directions. The obvious fix is just to turn one around. However, this will turn out to cause problems later. Let's check how this is working. At this speed, this looks great. There is ample power for the 10-car train and it traverses my curves and gradients without any hint of a slowdown. This would not climb my gradient before. It would stall out with only 2/3 of the train on the gradient. Let's try running it slower to make sure momentum isn't playing a role here. Running quality is great, no hesitation, and it walks up the hills without any complaints. The motors are working perfectly together. But something sounds off. Let's try slower. My NDM has a ticking sound coming from it that the factory one doesn't. It's quiet to the point you can't really tell at speed, but it becomes noticeable at low speed. I suspect metal-to-metal contact has something to do with this. Plastic pins would probably be fine, but I used a metal pin and it will be in contact with the metal flywheel. This could easily be responsible for this noise. I also have a problem with ABC. When the ABC kicks in, one motor does not stop. If I try to back out of an ABC section, that motor does not go. It's reading the ABC inverted as if it's applying to the opposite direction of travel. There are probably quick fixes I could do, but I want this to be able to run with a consistent set of settings applied to both decoders and no obvious bodges. Like intentionally plugging one decoder in backwards, for example. So I'm going to take both apart and compare them to make sure they both have red on the same side, go in the same direction, and stop with the same ABC polarity. Sure enough, in the train I had red on opposite sides. Turning one round makes it go the wrong way though. I can fix that by flipping the motor. I need to desolder the wires, flip the motor over in the cradle so the wires will now go to different terminals, and resolder the wires. To address the noise issue, I'm going to wrap the metal pins in some thin heat shrink. That should insulate them enough to avoid making metal-to-metal contact. I don't recommend this. This plastic is not heat safe, and I had to be very careful to activate the heat shrink and not affect the plastic. With that resolved, time to reassemble. Only to discover a problem. The body won't go on. It turns out the upper and lower halves of the body can only go together one way round. There's a key on the spigot at one end. This means I need to rotate the lower body half so it is the same way round that the upper body needs to be. With that reassembled, let's test this out. The good news is I fixed the ABC, which is now behaving perfectly. Both motors stop smoothly and in unison. Bad news is the tick sound has not gone away. It wasn't what I thought it was. At least I've eliminated my own designed parts, and now I know I'm looking at Hornby's parts. It's very difficult to find the source of a noise on a moving loco like this, so to look into this further will require some new tools. A rolling road may help here, but I don't have one of those, so that will have to be the subject of a future video. See you next time up here in the study at Donget's Model Railway.